Hello again, dear friends, and thank you for being with us in the first video of the Python programming language training series. Okay, we return to the program we wrote in the previous video. I fully explained the first line in the previous video. I mean this line. I hope you understand well what this line does. As I said before, in this way you can access modules and submodules. In the next line, we have used a data structure here. Like the standard library, there are various and powerful data structures inside Python. What is a data structure? Those are spaces and structures that you can keep data in. These data can include numbers, strings, or a combination of data types. What we used here is a list. The list is marked with square brackets. Lists are very powerful. In the next chapter, we will talk about them in detail, what facilities they have, and what can be done with them. Here we just want to see an example. For example, this list only contains numbers. You can write numbers, strings, or a combination of both types inside the lists. They are very powerful. In these three lines, we have put odd numbers from 1 to 59 into the odds list. As you can see, we have written this list in several lines. When the interpreter has seen the opening square bracket, it does not consider the list as finished until it has seen the closing square bracket. This is the opening square bracket, this is the closing square bracket. An interpreter starts from the beginning here, and because it has not seen the end of the list, it has not considered the end of the line as the end of the list. When interpreter reaches this point, it does not consider this point as the end of the list because there is no closing square bracket here. You can do this to prevent the program from becoming multi-page. A very important point about Python and its comparison with other powerful programming languages is the feature that makes Python very powerful and easy to work with. The name of this feature is dynamically typed and there is statically typed in front of it. Suppose you want to define a variable in Python. For example, consider the variable a equal to 5. The variable a equal to 5. The type of this variable is defined dynamically. You can see that the a's type is integer, which is the type of the 5 number. Suppose we want to change it. For example, consider a is equal to the string abc. A is equal to a string abc. Now let's apply the type built-in function on it. Yes, you can see that the a's type changed to a string because its value has changed to a string type. As you can see in Python, when a was equal to 5, its type was integer. When we change the values, its type also changes. So the variable receives its type dynamically from its value. Those who have worked with Java and C languages know how wonderful this feature is. In other languages, there is a need to define type separately. But in Python, such a thing is not necessary. For example, in our program, the type of odds is a list. Let me back to our program. Yes, here the type of the odds is a list because the value assigned to the odds, which is what you see on the right side of the draw, is a list. So dynamically Python considers the type of odds as list. The third term is again an assignment here. This is an assignment. That is, the expression on the right is assigned to the expression on the left. But here, the result of calling a function, or in other words, a method, here the today method, is assigned to the left side of the equation. The today method returns at the current time, and using the minute property, you can access the minute of the current time. So in this line, we create an object of today's current time, and then we receive the minute of this time and assign its value to write this minute. Now we have to compare this value stored in write this minute. We have two methods for this. You can see that I have written the second method as a comment. We store the current time in the time now variable. Then we save the minute in write this minute. That is, we store separately. But this is not common in Python unless you want to use the time now variable in future lines of your program. So keep this point in mind. Now we want to compare the stored number of the current minute with the numbers in the odds list. Python has great facilities and operators for such operations. For example, the in operator is one of these operators. The result of this operator is true or false. If the first expression is inside the second expression, the result of this piece of code is true. And if not, the result is false. If write this minute is in odds list, the result is true, otherwise it is false. And this column sign specifies which of these statements to execute. If the result is true, the first one is executed, and if it is false, the second one is executed. That is, if write this minute is in odds, the odd minute message is printed, and otherwise the not an odd minute message is printed. The interesting thing to note here is that we don't have curly braces in Python. In other programming languages, we use curly braces to specify the code. For example, in the if condition, we must have curly braces, but in Python we don't have curly braces when using conditional if loops. Rather, we have indentation. That is, we started the next line a little further. You can see it here. This is a very important feature for reading codes. If you are not familiar with other programming languages, this point will not matter to you. But if you are familiar with other programming languages, this point will be interesting. If you do not consider this point, for example, do not consider indentation, you will receive an error. We can check it. For example, let's write if, let's define the variable b is equal to 6. Then let's write, oh, what does it? Let's write if b less than 10, print less, for example. Print, oh, that is print less. You can see that there is a syntax error, and this is that famous red square here, which is the place that the interpreter guesses maybe the error might be happened there, you know. So the indentation should be followed. This feature makes that when reading the program, one look is enough to understand the program. Another feature of these conditional blocks are these columns. These columns. There are always these columns in conditional phrases. Another point is that Python programmers, unlike programmers of other programming languages, do not call these blocks of code blocks. They call them suites. Python is indentation sensitive. This sensitivity is available in all lines of Python programs. We checked if and found the reason for the indentations. We will explain further and more precisely. Another point is that when programming in script mode, there is no need to keep open Python shell. As soon as the program written in script mode is executed, Python shell will open automatically. Let's try it. Let's close the Python shell. Press the F5 button in script mode. Let's press OK on the save message box. Let's give a name for our project. Don't forget the .py extension. And you can see that in the time of execution, the Python shell will be open. So there is no need to keep open the Python shell during the execution, during the programming in script mode. In addition to if and else usages in Python, Python programmers also uses else if, which is abbreviated as elif in Python. Elifs are always between if and else. Using these, you can write various conditions in Python. We can have multiple elifs. Let's check it in Python shell. For example, let's define the variable a is equal to 3, the variable b is equal to 7. Let's see if no. Let's type variable c as for example, variable c as 10, variable d as 1. Okay, let's see if a is, for example, less than 5, print, for example, true, no. Oh, if a less than or 5, print true, L if a is less than, a is bigger than 5, print false, for example, else print A is equal to 5 phrase. For example, you can see that because the A is less than 5, actually, because we defined it 3, the first message which was true was printed. But if we apply this code, if we copy paste this code here and we apply it on the B variable, you can see that the result will be different, because B is equal to 7. We defined B as 7. You can see here that this message, which was false, was printed. There could be lots of other states, and you can check any other examples yourself. Each of the Python suites can include any number of other suites. Indentations are also applied in nested suites. The important point in conditional expressions is that before using variables in these expressions, that variable must be defined. You have to be very careful with the indentations. Any slight difference in them leads to error. We have an initial indentation level here. Let's see this. Okay, we discussed about them. These are the word suite which is used for these blocks here in Python, and we are talking about this slide. We have an initial indentation level here which we call a level 0. You can see it here, which I marked with blue color. I mark the next indentation level with red color and name it level 1. You can see it here. And then we name the next level of indentation level 2, and we can continue in the same way. At first, we may receive some errors, and it is difficult for us to follow these indentations accurately. But with the passage of time, we will see what a great feature it is for reading our program. In Python, equal means assignment. We have already mentioned that this equality means assign the expression on the right side to the expression on the left side. During this assignment, the interpreter also determines the type of the left side of the equation. But two equal signs are used for comparison. Let's back to our program. That is, to compare two expressions in Python, we use two equal signs in a row. If these two expressions are equal, the result is true and false otherwise. These were the initial explanations about these few lines of code. Let's make changes to this program. First, let's repeat the program. That is, it should not be executed only once, but 10 times. To make it more interesting, we can add a delay, and it will be more interesting if this delay is random. It means to specify a range of numbers and randomly select the program delay number from this range. There are facilities for each of these in Python. For example, you can use Python repetition loops for repetition, like for or while. For is used when we know the exact number of repetitions. To stop the program, Python has interesting features such as sleep, and for random selection, you can use the random module. To perform these 3 steps, you can use the Python documentation that we talked about at the end of the previous session. For example, search for while, sleep, random, and find out the rules of using them as well as their features. But the second way, which is more popular among Python programmers, is personal experience. It means try different solutions and different features of these facilities yourself. This wonderful Python shell is at your disposal for this testing process. Both approaches are done and correct. However, the latter is more common. That is, first we try in Python shell and then we transfer the safe codes to the script mode environment. If we know the number of repetitions, we should use for. But if, for example, we want to stop the program if something happens, we must use while. There are several ways to use for. The first method takes a list of numbers and executes the code once for each number in the list. Okay. Let's bring it here. Okay. In Python shell, when we write the column after for and press enter, the indentation is automatically observed. In order not to observe this indentation, we must press enter twice at the end of the code inside for. Let's see. We can say for I in let define a list like, for example, 1, 2, 3, 4, for example. Insert a column sign and press and enter. You can see that the indentation is applied. We can see, for example, print I itself. If we press the enter button on the keyboard one time, we will have this indentation and nothing will will be run. If we want to run the loop, actually the repetition loop, and we want to exit the loop, we want to we don't want to actually see the indentation, we should press this enter button twice. You can see that when we press the enter button twice, the for loop was executed, and you can see that these i's, which are 1, 2, 3, 4, are printed. This I is called a loop iteration variable. Here the parameter inside the print is the same variable. The second model is to use for on a string. Actually, this for works on a sequence or a set of objects. For example, you can have for letter in hello, insert the colon sign, press 1 enter button, and you can, for example, write just print the letter. Okay. Press the enter button 2 times, and you can see that the for loop was executed, and these letters inside the string are printed here. The third model is to use a built-in function called range. In its most basic state, this range takes only one parameter, which is a number, and specifies the number of repetitions. For example, you can see that for I in range, for example, 4, insert the column sign, press enter button 1 time. You can observe the indentation. You can, for example, write print a phrase, for example, how are you now, for example. if you press the enter button twice, you can see that this loop will be executed. Okay, I forgot to insert the closing parenthesis. Now if we enter the press the enter button twice, the for loops will be executed. You can see that the phrase inside the print function is printed 4 times. Why? Because this 4 was the input of the built-in function range. In the first method, the number of repetitions of this loop is equal to the length of the list. For example, because here the length of this list is 4, the time the amount of repetitions is 4. In the second method, the number of repetitions is equal to the length of the strings. And here, because the length of this string is 5, so the number of repetition of this loop is 5. You can see that. Okay, the standard indentation in Python is equal to 1 tab on the keyboard or 4 spaces. Let's see. For example, we can insert 1 tab. You can see that this is 1 indentation. Let's see. Let's try the space. 1, 2, 3, 4. You can see that this is here. This is 1 indentation actually. Okay, let's come back to our program. To apply repetition, we need to indent the if loop, this loop. We can move the lines forward one by one with tab or by selecting the desired lines and pressing the tab key to reach the desired result. We can one by one send these lines 1 tab forward, or we can select these and press a tab, or there is another way. Indentation can also be done by selecting lines and using the Format tab. Also, the shortcut keys here are defined for you by Python itself, which may sometimes be different depending on your operating system. You can select these lines from Format header. You can use indent region, and you can see that the indentation was applied. Okay, thank you for being with us so far. I emphasize that from the next videos we are just getting into the main topic of programming in Python, and so far we were only getting to know the basic concepts. Have a nice time.